Welcome everyone. If people haven't been on a Zoom webinar before, this is my first time hosting one, so forgive me if I mess up in any way. Just let us know in the chat where people are sort of joining from. There's a chat functionality at the bottom. There's also a Q&A functionality as well. So if you've got any questions during the presentation by Gordy today, if you can put them in the Q&A chat rather than the actual chat box, just so we've got them all in one place. Just wait a little bit longer, Gordy.
Yeah, no problem.
Tuning in. How long will it be, Gordy, today? Your presentation, do you think?
30 to 40 minutes, I think, depending on how many questions there are along the way, and how distracted I get with things. But yeah, it shouldn't be too long. I'm hoping that it's the start of a good conversation though, and I've got time afterwards for lots of questions and to chat to people.
Yeah, I was just going to mention that if anybody throughout this this presentation tonight has got questions, please do put them in the Q&A box. I think that there will be elements, am I right in saying this, Gordy, that where it might be better to ask a question if anyone's got a question that's particularly pertinent to anything Gordy's saying, just pop it in there, and it may be that we can get that within the sort of the presentation itself rather than at the end.
Yeah, that's definitely true. So particularly when we're going through some of the lessons learned, I'm hoping that might spark some conversations around each one of those lessons. So it might be worthwhile piping up with questions at that point.
Yeah, brilliant. Welcome everyone. People still joining. Where are people joining from tonight? If you just pop in the chat box. We've got Gordy's down in Oxford, which is probably one of the beauty of webinars rather than the in-person meetups. Obviously, a lot of people will already know us from hosting these in the flesh in our Glasgow office, but in these times we've all got to be quite sensitive about that and sort of do what we have to do. So we've adapted. We're on Zoom now. We're hosting webinars, but like I say, the beauty of that is that we can have Gordy from down in Oxford who's talking. Hi Paul from Greenock. Hi Stefan from Dublin. Nathan Salford. Hey Dominic. How you doing, Gavin? Still getting a few more just joining in, so we'll just give it another couple of minutes before we kick off.
Hey Ned, nice to see you.
Hi Mark. So I'll just repeat again, there's a couple of boxes down there. Pam from New Yorkshire, if you can pop any sort of chat in the chat box and then any questions in the QA box, and that'll just help to sort of separate things, so that we're not losing any really good questions during the presentation within the rest of the chat. There we are. Thanks, Pam. Seems like we've got people from all over the UK, really. Salford, North Yorks, which is good.
That is good. That's very interesting. Quite excited.
Yeah, I imagine we might get a couple more joining, but we are at sort of at 5 past, so we'll sort of kick off fairly shortly. So yeah, welcome everyone that has joined. As you're aware, we usually run these in person in Glasgow. Time's permitting, we've now moved over onto Zoom, onto the virtual events. I hope everyone is really well and looking forward to this. I certainly am, to tonight's webinar. So we've got delighted to welcome Gordy from Intelligent Growth Solutions. Now, I imagine some of you will know what Gordy does. Those of you that don't, Intelligent Growth Solutions are a really, really exciting startup based out in Edinburgh. Obviously, Gordy's down in Oxford, within the sort of agri-tech space, and specifically vertical farming. If any of you have watched sort of David Attenborough or any of those sort of things, you understand the importance of sort of ensuring that the increase in population can be fed and be fed sustainably. With vertical farming, there's obviously loads of technical challenges, and Gordy's going to talk us through their technical journey so far, the challenges that they've faced, and their sort of overall aim as well. I'll quickly repeat, if you've got any questions throughout Gordy's presentation, please do pop them in the Q&A box below. Any other chat or anything, put that in the chat box. That just helps things sort of stay separate, and it allows me, it makes my life a little bit easier when I'm keeping track of the questions that we've got. So Gordy, are you ready off? Are you all set?
Yeah, let's go.
Smashing. I'll go dark, I'll go quiet. I will let you crack on and share your screen. Hope everyone enjoys.
That screen, there we go. Okay, so welcome along. I'm Gordy Wills, and I'm going to talk a little bit about our vertical farming journey, as you just heard. Presentation's broadly broken down into about 3 sections. I'm going to go through some marketing and sales slides that I've literally taken from the market, an idea of what that really means. Then I'm going to talk to you about the challenge that I faced about a year ago, and then instead of going through all the history of how we met that challenge, I'm going to jump straight into some lessons learned along the way, and talk about those sorts of things. If you've got questions, obviously pipe up as we go. So before we start anything else, there's a little question, I guess, on why is a guy from Oxford coming to talk at Glasgow DevOps, and it would appear that that lots of people from around the country join Glasgow DevOps. So that's really quite exciting. The reason being is IGS is an Edinburgh-based company. Our CEO is a serial entrepreneur, very Scottish, and I do really mean very Scottish. Very proud Scot. So we're based in Edinburgh. The original idea was conceived in Dundee, with some work going on there, and our experimental farm is still actually in Dundee. So we're very much a Scottish company, despite the fact that I'm down here in Oxford. I am the head of software engineering. I'm not sure really what that means, other than the fact that I get to do all the leave requests and that sort of thing. But that's my role. I am an agilista. That's a nice way of saying that I really strongly believe in the principles of agile in the manifesto, and in behaving in that sort of customer first, short iteration, get value into the hands, and focus on that feedback rather than milestones or anything else. We practice Scrum at IGS. But quite frankly, anything that involves an agile mindset is important to us, and it's filtered right through the whole company. So from CEO down, my CEO genuinely understands agile, and we have a sort of agile approach to many things. I'm also an online gamer. I handle Zizmbard in case you want to sort of find me anywhere. I despite the look of me, I am also a long distance walker. Just really enjoy doing that, and a bit of an amateur astronomer, mostly naked eye astronomy, taken from too many nights spent outside as a young man in various places around the world. And it's nice to see familiar shapes in the skies. It's also really important to know that I'm a bit of a DevOps numpty. When we learn the lessons, I'm hoping that you've got some answers and you've got opinions on those, and I'm really keen to learn from you guys as much as hopefully you can learn a little bit about IGS from me. And as I said already, I'm a filthy Sassenach, but I think that's okay because pretty much the rest of the company is in Scotland. So I'm going to talk to you about about farming and vertical farming, and it can sometimes seem like, well, why is farming such an important thing? Because we've been doing it surely for millions of years. We know how to feed people. We've been feeding them, and that's great. But it's a truism to say that farming is straining under the pressure. We have been for the last 40 to 50 years overgrowing our topsoil. We've used up all the nutrients in it. It's starting to blow away into the wind. So the amount of agricultural land in the world is decreasing. At the same time, our population is increasing. Vertical farming is just one way that we can look to do alternative farming practices. So vertical farming, indoor farming, or as we call it in our company, total controlled environment farming, or total controlled environment agriculture. It's a way to do that in a factory scale, in an industrial site, in the center of a town, etc., not taking over that already very constrained space, which is agricultural land worldwide. So this is one of the keys to why we think now is a really important point to start injecting this level of technology into farming. And these numbers are very conservative. So 9.7 billion by 2050. Those are conservative numbers from the United Nations. There are charities out there who will tell you those numbers are too small, and we should be looking up closer to 11. Either way, it's a lot more people than we have now. The James Hutton Institute, which is a Scottish crop research organization, they've done a bit of studying around that. 9.7 billion humans. What does it really mean? And bizarrely, despite the fact we're only going to go out by 3 billion humans in the next 30 years, there'll be a 50% increase in demand in food. And that's because not only are we increasing the overall numbers by 3 billion, but we're increasing the middle class and the wealthy, that the numbers worldwide of those are going up. And so the demand for food, the demand for convenience, the demand, the waste culture that we end up with will put a 50% extra demand in food worldwide. So we have to do something, because we're not able to increase our land by 50%. My CEO does a great trick with an apple at this point, where he cuts it in half and says, right, those are the oceans, throw that away. And then he cuts what's left in half and goes, those are the mountains and the deserts, and you throw that away, you cut what's left in half. That's the poles, you cut, and he keeps cutting it in half until he ends up with his tiny thing and goes, that's all the agricultural land in the world. And it's absolutely true. And as we increase that demand in food, it becomes really difficult. The other real key for us, and something we've been focusing quite a lot in the hardware side of the technology, is about the fresh water demand. It takes somewhere between 1.5 and 2.5 thousand liters of water to produce 1 kilogram of cane sugar. So when you go and buy a pack of cane sugar from the supermarket, it's taken between 1.5 and 2.5 tons of water to produce that sugar, which is an enormous amount. To put that in context, 2 tons of water is enough to give 600 people their water for the day, or to give you water for almost 2 years. Just think about that for 1 kilo of sugar. And sugar is really sort of central to where those demands in food are going to go up. So fresh water demand is going to be huge. So you can see there's a massive impact here on what we see in terms of the farming landscape. So at IGS, we're trying to look into what we can do in order to inject technology into that problem space. Technology can solve a lot of things. Technology makes a lot of things better. And what we're looking for is these vertical farming platforms that create indoor environments. Those indoor environments, I'm going to talk about a little bit in a minute, but they're all about making sure we've got the right sun and rain and that sort of stuff. And we've got to we've got to drive a different way of thinking, and at OGS, that's one of the key motivators for us, is not only to get our vertical farms out in the world and be commercially successful. That's definitely important, but we also want to start changing minds about how we are going to feed our population in the future. And we need to really think about how we're doing that. So vertical farming is where we're focusing our efforts at the moment. We're hoping that will help with driving a change in technology as well. So when we talk about vertical farm, if I go back to this picture, you can see the hangar in the background of this picture. Well, this is what that hangar is in a sort of cutaway mode. You can see here inside we have these what we call the towers. The towers are a set of shelves on either side, and then these grey boxes that are on them are a tray. It's about the size of a full-size snooker table, just slightly larger, and we move those trays into the bottom of the tower. There's a lift in the middle that takes up and slots them onto the shelf, and then can slot them back out and take them out once we've done growing. So you can see here how we are creating a vertical space and using floor space again and again and again. Just to dumb it down the way my marketing guys like it, we're talking about farm in a box. And you can follow those steps along from one, start with the field, cut it into bits, stack them on top of each other to stick them in a box. And that's pretty much what we're doing. We can get around about 300 square meters of field into a 40 square meter building, which is quite a lot. That 40 square meters of building, a lot of that is overhead. So if you put more than 4 towers in that building, you increase the footprint of the building, but you actually increase the growing space by more than you increase the footprint of the building. So that's this idea that as you get big and do this at scale, you get economies of scale and efficiencies. The difficult part is this bit, step 5, make the climate inside. Outside, the sun is free, the rain is free, the soil is free. The difficulty with that is that sometimes it's cloudy, sometimes it's sunny. Inside, it's always the perfect light conditions. Sometimes it's rain, sometimes it's drought. Inside, it's always the perfect rain with always the perfect nutrition, always the perfect acidity balance. Sometimes the wind blows, sometimes it's hot, sometimes it's cold. Inside, that's not the case. Inside, it's always exactly the right thing. So not only can we make a climate, we can make very specific climate. I want to show you a video which is from the marketing team. And you can see then some of these aspects and some of how we're building those climates inside.
Intelligent Growth Solutions is an agritech innovator, designing and selling a revolutionary controlled environment growth system. 2 to 3 times crop yield with quality and consistency. 50% less energy. 80% less labor. Each tray is in its own climate. Separate ventilation, irrigation, and illumination. No on-site computers with all software in the cloud. Water is reclaimed through a closed-loop irrigation and filtration system. We reduce labor through automation levels suited to your business model. The controlled environment eliminates pesticide use for cleaner, healthier produce and longer shelf life. Co-located on the campus of the James Hutton Institute in Invergowrie, we built a fully automated vertical farm demonstrator. Not commercially selling produce, the facility allows us to run experiments and partner with the James Hutton Institute on additional research programs. Tours are regularly given to interested organizations. For more information, go to intelligentgrowthsolutions.com.
Okay, so there you get a feel for what the farm looks like and how it moves, and what sort of thing we're talking about. Clearly, I've mentioned already, these are the things that we control. This kind of environment that we control. And that's great because it means that if you're growing basil grows most ideally in Tuscany. I can produce summer in Tuscany all year round, the most perfect summer in Tuscany in each tray, so I get the most perfect basil every time. So that's giving plants that have evolved in a particular environment what they need for what they evolved for. But the brilliant thing about evolution is that it's not a closed door. So we can start messing around with some of this stuff. And maybe there's more perfect summer in Tuscany than a perfect summer in Tuscany. So we can start playing with some of these things, particularly around light and air mix and that sort of thing. But the thing we can mess around with most is when the thing works is time. It really interestingly, we don't have to have 24-hour days. So we can have really short days if we want. And plants respond to that in some interesting ways. If your days are too short, they die. If you lengthen the amount of day there is, then they tend to grow quite tall, and then their flavor profile drops down. But you can really start playing around with time, and that's an interesting thing, and that's something we're looking to for the future. And we're not quite there yet. What we're doing still at the moment is reproducing Tuscany in a tray. But as we are able to gather data out of the system, we're going to be able to start tweaking around time as well as all of these other factors, and it'd be really, really good fun. Okay, so that's a really quick overview of what it is. I say quick, it's been 16 minutes. Sorry about that. But that's an overview of the company and what we do. There's so much more to it than that, and there's so much to learn. But we could literally be here for hours, and I would do the talking for hours, talking about things. So I'm going to end the sales pitch and the marketing slides there. I'm going to start talking about my challenge. Harry, have we had any questions so far that sort of fit into what I've talked about so far?
No, we're all good to go.
Excellent. Okay, so that's what it is. And the company has been around for quite a number of years. And most of that time they've been funded by research grants. They've been funded by wealthy and interested individuals, that sort of thing, and they've been building that machine and learning how to build the hardware technology. And they took a number of years to do that, and it was worth it because it's done really well. About a year ago, we got our Series A funding as a startup, and we needed to start commercializing what we had learned. That's when I came on board the company. David, the CEO, who's a friend of mine, he gave me a phone call and he says, "Hey, Gordy, come write the software. And I need it to be scalable, extensible, and maintainable. Oh, and by the way, right now there's only one part-time software engineer, an R&D software engineer who needs to continue to support R&D. But you've got my support. Let's get it done." So a year ago, that was what we had, and he he used the word scalable, extensible, and maintainable. He doesn't actually know what those mean. He's a brilliant CEO. He's a fantastic entrepreneur, but a software engineer he is not. But what he did know was that the experimental software wasn't going to cut it for customers. It was split apart into different sections. It was it had some unreliabilities in it. It was it was difficult. It's been brilliant to get the machine where it is, and it continues to be brilliant in the R&D team, helping them to learn new things. But for our customers, we needed something slightly different. So that was my brief, right? "Quote unquote, the software." And I didn't know what it was, but I knew it needed to be scalable, extensible, and maintainable. So perhaps by investigating those, maybe I could understand what it was we were going to build. So let's talk about scalability first. Why do we need to be scalable? Well, there's a classic sort of software diagram. You could replace firmware with SQL driver, and you could replace hardware with database. And that would be something, that would be a fairly familiar thing. And sure, if we're going to get millions of users on the front end, maybe that would be something I need to scale for. But actually, we've just said in that video, no, we're reducing your labor by 80%. So we're not going to get millions of users on the front end. What we're going to get instead is we're going to get loads of users on the back end, because the other thing you heard in that video is there's no computers on site. So I don't have any edge devices out there. I have to connect from the cloud to each one of the bits of firmware. Wow, I've just spotted, I've called that firm war at the top. So that's connecting to each bit of the firmware individually, because the firmware runs on a piece of electronics used in industrial automation called a PLC, a programmable logic controller. And those PLCs are each individually addressed, and I need to address them from the software. So in our 4-tower site in Invergary, the one you've just been shown around on the video, this is the connectivity we have. And I have one customer who is our plant scientists. Well, I say one customer, there's 4 or 5 of them, but I have one account, if you will, who are the plant scientists who are doing the research up there, and they need to be able to do that. So look at all those arrows, and then imagine what happens when I stick a customer into the mix. Suddenly I need individual connections to all of these things. So the scale here is not necessarily about the number of users. The scale is about the number of bits of hardware. It's really important that we can do that. In fact, it gets worse because, you know, pretty early on we're looking at customers, and these are kind of the shape of the sort of customers we want. The gray is still the research farm in Invergary, but we're looking at small customers who maybe have 8 towers. We're looking at medium-sized customers, one site with maybe 30 towers on, and then large customers with multiple sites, you know, each with ridiculous numbers of towers on. And suddenly, you know, imagine how all those blue boxes scale out. We need software that can manage all of that, that can manage the instructions to the firmware to make sure that the towers are growing what they need to grow. And ultimately, you know, within 3 or 4 years, we're hoping that there will literally be thousands of towers out around the place. If you look at the numbers just from 4 customers there, that's a couple of 100 towers, more or less. So it only takes, say, 20 customers, and suddenly we've got 1,000 towers out there. So we've got to be able to scale this, and it's a really, really hot market. So assuming that we might have 20 customers at some point in the future, it is not a massive leap. So there we go. I understand now why it needs to be scalable. I sort of understand now that the software needs to send instructions to all of this hardware to make the hardware do what it's going to do. The hardware is very good at controlling itself, at maintaining its own temperatures, that sort of stuff, but it needs to be told what temperatures to aim for. It needs to be told what water it needs to deliver. It needs to be told what pH that water needs to be at. I mean, it will sort out getting the pH there, but it needs to be told all of these things. And then it needs to be told that not per tower, but per tray in those towers. And you saw there were loads of trays in those towers here. So there's 27 each side, making for 54 in total in the tower, and then there's, you know, possibly 40 towers. So there's loads of trays, and each tray needs its own set of instructions, and its own set of instructions need to be channeled through the PLC controlling that tower. So you can see how here it becomes a really, really big back end problem as opposed to a big load of users that you might expect. But extensible, why do we need to make it extensible? Surely, you know, we're not going to change the hardware all the time. We're not going to add features to the hardware. So why do we need to make the software extensible? Well, because we are going to change the hardware and we are going to add features to the hardware, but we're not going to do it inside the tower. The tower is one small part of the process. Okay, so that's what we're focusing on right now, and that's what we're building right now. But as you can see, there are up here, this line of stuff is about putting seeds into substrate and germinating them, and doing that inside the sort of plastic propagation trays or Danish trays that you would recognize if you saw, you know, the kind of how plants get sold in a garden center or whatever. So we have to be able to seed stuff, then germinate them and control that germination and report on that germination. Then finally, we load them into one of the snooker table size trays and stick them in the tower. We do all the growth in the tower, all that clever stuff in the tower. Then we take them out, and immediately the tray gets sent back through its cleaning system and cycled back through. But the propagation trays or Danish trays, they come in, the crop gets harvested off the top and needs to get packaged, and then the propagation trays themselves need to load out. So you can see there's a huge system in here, and at some point the software needs to be able to trace, monitor, control, interact with other software. We don't really know yet. We're still figuring that out. All of this other stuff. Right now, we've got to get the tower right, and that's what our first customers are expecting. But we've got to extend this out over time. So, okay, so now I know a bit more about what it was I'm trying to build. And then along pops this fella, and this is the an Omron robot. Omron is a industrial automation company. That's what they do. They build a lot of PLCs, and they've also built these clever robots. These robots are designed to be put onto trolleys, and we're going to give it a trolley that holds one of those snooker table sized trays to drive around the facility. So no humans need to even go in the facility. The humans prepare the trays and stick them on the Omron robot, and the Omron drives into the facility and loads them into the correct tower and that sort of stuff. Well, we don't control robots today, but we will need to in the near future. So we need to be able to make sure our software is extensible enough to be able to add in that kind of stuff. Because if we have to completely refactor the whole thing in order to add a feature like this, then we're on a hiding to nothing. So then I guess I asked, why maintainable? And it has to be said, if you don't know why maintainable, then maybe, just maybe, we need to have a bigger talk. It's got to be maintainable. There are going to be bugs in it. Everything's got bugs. We've got to be able to fix it. It's got to be able to be something we can trace through in a sensible, logical order to find the bugs and fix them and make them right. So maintainability is it's a given, but we had to do it. Okay, so now I think I understand my challenge, or do I? Well, sort of. I kind of know what the broad requirements are, but here's the real challenge. Build the software, kind of know what that is, and you've got one part-time software engineer. Okay, well, what is it do I actually need to build? And you start with this blank piece of paper, and that seems like a gift. That seems like something that you always want to do. You always want to have a blank sheet of paper so you can do stuff right from the beginning. And we'll see, maybe that's a lesson learned, that maybe you don't always want a blank sheet of paper. But I know certainly when I've come on board legacy projects in the past, you go, why didn't you just build this right in the first place? If only we were starting from scratch, it would be so much easier. So what I did is I took that blank bit of paper and I wrote down literally everything I could think of in terms of what I would need to put together. And you can see here, some of these things are big, some of these things are small, some of them are confusing, some of them are technical, some of them are soft systems and everything else. And you can see there's a lot of it. You know, when I was preparing this presentation, I did the blank sheet piece exercise again, and this is what I came out with in just 5 minutes. So you can imagine the sheet of paper that I did this for real on, which I couldn't find. I was really upset. I was hoping to find it and take a photograph of it, but it's much bigger. And I spent 3 or 4 weeks thinking of things and teasing them out and sort of, you know, what do these things mean? But I've got to do all of this stuff. And you know, there are some things in here which sound simple but are not. Team. I've got to build a team. That sounds like an easy thing to do. Just go out and recruit some software engineers. It's really not. It's a big ask, and it's a difficult thing to do, and it's a difficult thing to build a good team that works together. Pipeline. Well, you're all DevOps engineers, or have a healthy interest in DevOps. So, you know, pipeline's easy. You just write a little YAML script and it puts stuff together. But when you've got things as complex as PLCs that you have to interact with, you need to try and simulate them. You need to simulate your PLCs and things. Because I've put testing as one of the things, I also need to build into that pipeline automated testing. Because I've got coding standards somewhere down here. There it is, coding standards. Because I've got coding standards and quality measures that I want to meet, then actually I need that pipeline to fail. And so that pipeline in my mind gets massive in terms of the volume of stuff it has to do. You know, all of this then, you know, what sort of branching model do I use? What architecture do I use? So is it microservices? Is it something else? I also then have to do this all to a cost. I mean, we did get funding, and we got quite a lot of funding for a startup to get us through the first thing. but it wasn't a limitless amount of money. It wasn't stupid money. It wasn't Google money. So I had to do it all on a budget. Then I know that we need a production environment and a staging environment and a test environment and development environment. And well, actually, because of the fact I want this pipeline and want to do coding standards things, I'm want to try to generate an environment per pull request. And so there's all this stuff to do. And then we have to not forget that the clock is ticking. You know, at the time when I came on board, I had a little over 12 months to deliver to my first customers. What that's going to turn out to in real life, it's going to turn out to about 15, 16 months from blank sheet of paper to customers live and having to build it out. So you can see we've had to move very, very fast. And that's why we've learned a lot of lessons. So we're actually 12 months in, just over actually, since we started. And we've only really been sprinting for 9 months. We started sprinting sort of midway, late half of January, and we've been sprinting since. Brilliantly, we replaced the R&D software in the research center just 3 weeks ago. So the research center is now using production software, and we've already learned a whole bunch of stuff about that from the feedback we've had in there. So along the way, we've done some stuff right, we've done some stuff wrong. As I said at the beginning, I could give you a detailed history of all of that, but it would take hours, and I don't want to take hours. I want to start discussing things, and some stuff, well, there's a bit of divided opinion. So we're not sure what we've learned so far, but we know we're going to learn something from it one way or the other. So before I go on and talk about the actual lessons learned, Harry, are there any questions about what I've been saying about the challenge?
We have got a question, yeah. Brian has asked, curious as to why there are no on-site compute. Was this a design decision? I would have thought some edge technology would be helpful, especially from a downtime perspective.
Yes, I agree with you. The decision was made prior to me coming on board, and it comes from a position where when the product was envisaged, we were envisaging selling it to actual farmers. We realize now we're selling it to industrialists. And what we didn't want to have to do was replace low skill labor, low skill cheap farming labor with high skill sort of system administrators who could run the data center that is inside your farm. So the idea was to reduce the amount of computing entirely. And to start with, we thought we could pull it away. What we're learning now is that some of the things we're trying to do rely on that communication thread so much, and the network step is costly, that we've got to try driving some of that down. And so I suspect that soon there will be an edge device on site. What we're not going to do is put a lot of computing power in there, and we're going to keep the main thrust of the logic and the software in the cloud, because that helps us for sort of commercial reasons as well as technology reasons. But one of the key things is this needs to be simple to operate for our customers. And what we don't want to do is give them computing headaches that they don't need to deal with. So that it seems likely that in the near future there'll be an edge device, but it'll be a hardened edge device that'll be super simple. I hope that answers your question. It's not a brilliant answer, I know, but I'm hoping that in the near future we'll do something different. Anything else, Harry?
We've just had another question come in. Yeah, it was Brian says that makes sense. Thank you, by the way. Okay. Pam has asked, what did you have in place before you started sprinting?
So we started sprinting really once we got the team together. So what we had in place was me and the part-time software engineer who went full-time, which was a joy, and me. And it was about working out what we were doing, what we were thinking about, how we were working. And because it was just the two of us for a long period of time, we were able to Kanban effectively. We weren't really Kanbanning, we weren't doing the full thing, but we could Kanban through our weeks. We brought on board a Scrum Master in late November, and she was able to then get us into a position as we filled out that first team to start sprinting in the January. So up until then, we were doing our own level of research and our own level of kind of architecture and that sort of stuff.
Another anonymous attendee just commented here saying, thankfully, industrial computers are a pretty standard thing.
Yeah.
And concerned about the connectivity of site that could be poor. Edge may make sense in those sorts of circumstances.
No, I totally agree. Connectivity issues is one of the things we are most scared of. But we have built into the design of the platform, we've built in this idea that if we lose connectivity, we understand we've lost that connectivity, and we can recover from that quite gracefully. Thankfully, plants are pretty resilient. So if you mess them around a little bit in terms of their lighting regime, their watering regime, and that sort of stuff, they'll recover. But if you mess them around a lot, they don't. So again, we're learning that stuff out, and it's connectivity more than anything else that I'm worried about. Although we do say to our customers that one of the things they have to provide us water, they have to provide us electricity, they have to provide us reliable internet. I mean, those are the things. So just like there has to be a road to get to the farm, we're saying that's as fundamental infrastructure as having a road to get to the farm, and so far our customers are accepting that as being valid. But a lot of our early customers are looking to site their farms in industrial spaces where there is great connectivity already, because it's an industrial space.
Brilliant. And Perkins has asked, how big is the team now?
So the team now, brilliant question, because I'm going to go on to my first lesson learned. So the question is to build the right team. You've got to build a team with sense of humor, with a sense of wonder, with an ability to work together and that sort of stuff. We're currently 14 strong, as well as the 12 you see here. We have another QA on team. I want to just check that I'm missing anyone out. There's me as well. We've got a third QA just joining the team shortly. We've got a second site reliability engineer joining very shortly. We're out recruiting. We're growing. We've got money. Our board has approved us to do more recruiting. But building the right team is key. So we're just at the point when you take away the overheads from this thing, we're just at the point where the Scrum team is teetering on being too big as a single entity. So we're just splitting it up now. We split it up by name. There's a little bit more work to do to split up the process. But getting the right human beings involved is very important. One of the things that you will notice about this picture is there are only 2 women in it. You'll notice also that there are a lot of Scottish men in it. There's also a Canadian man in it. There's also a French man in it. There's a Bulgarian. Sorry, Ado. So we do have a little bit of diversity, but we need more. We need fresher, deeper thinking ideas. But the important thing is to recruit for attitude around quality, recruit for attitude around why we're doing stuff. I mean, it would be very easy to build the thinnest slice of stuff to make the farm work and just sell the farm and stack them high, sell them cheap kind of mentality. But actually, if I go roll all the way back into the slide that shows that 9.7 billion by 2050, every single face you see here is fully invested in the fact that we're trying to change the way farming is supported by technology. We hope that we are at the center of that change, but there's potential that we might do something else. Hopefully that answers the team question. I mean, I feel we've done well and we've built a very strong team. We still need to build it out a little bit more. We need to balance out the DevOps side, and we need to increase our quality assurance engineer side. But we're building the right team of the right human beings that have the right attitude, I think, to be successful. One thing we did poorly is that we have flipped between trying to eat the elephant in one bite and forgetting to have a vision. So to start with, this was the original architecture diagram I drew. I'm sorry it's blurry. I'm not sure why that's happened. I think it's an artifact of doing clever animations with PowerPoint, which I will tell myself off for not doing again. But you can see it's quite complex, and it involved it looked at everything. It was data lake. It was detail about how we interact with the farm in detail, and there was too much here. We couldn't answer any question because every question sort of led to that, and how does that affect these other 25 things, and too many moving parts. So we focused a little bit more on trying to eat the elephant one bite at a time, and we came up with just, well, let's talk about the entity relationships then. And here you can see a sort of microservice layout with how we do storage and how we do messaging and that sort of stuff. But even that actually turned out to be too big, because these concepts were huge. So we refocused again after that, and we this is currently the sort of architecture we're running to, something small and bite-sized. Unfortunately, here we've lost a bit of our vision in terms of scalability in particular, because this path here to the command executor is a little bit single-threaded. So across all the towers, we have a schedule of commands, but this command executor only picks up one command at a time and sends it forward. So we need to do something. We need to come back and get back into our vision of being scalable about across how many we are. So that was definitely an error we made. But something that's helping us hold on to that vision in a great way is getting a great PDO, and we do have an absolutely great PDO. So although product owners are probably not thought as a central part of DevOps, they are a central part of making sure that you are doing small things really, really well, and small things really, really well allow us to do DevOps a little bit better, I think. Something else we did poorly is that during those early 3 months when there were just the two of us there, I'm quite a hands-on type guy, and I wanted to do things. And so what I did was I built a process that suited the team I was on last. And I had lots of different types of issue types with lots of different statuses, and different filters on boards and that sort of stuff, all built in Jira because I'm a masochist. And it all built out, and it was way too complicated. It's way too complicated. And I had a whole PowerPoint presentation about how to use the thing I'd built. And almost instantly we got the product owner on board. He created a thing you can see here called the holistic board. So just ignore all of my filters, ignore everything else, just get everything in one place. And I'll be honest, that's what we use for planning more often than I would like, but that's it. But you can see here, I've created this really complex process, which makes perfect sense to me. But then we brought a team in on board, and here we are, months later, and we're still unpicking some of the blockers in my own process that would have worked brilliantly with my last team. In fact, did work brilliantly with my last team, because they were doing that, and they still run this now, and it's great. But it doesn't work with this team because the challenge we have is different. In my last team, I was doing medical devices. In this team, we're doing industrial farm systems. So a real lesson for me is don't overcomplicate your process. Let it evolve. Sometimes that can be painful, but overcomplicating it early just gives you nightmares, or gives me nightmares anyway. Something we did quite well, I think, is we set a testing strategy early, and we decided to integrate that with release and the deployment pipeline. Too often, I have joined teams quite late on in their life cycle, and they say, yeah, well, we would do automated testing, but it'd be too difficult to reverse engineer it now. So you can see here the diagram on the right. You can see all of those diamonds represent some sort of automated test or several automated tests. And at any stage, if it doesn't work, throw it all the way back up to the top and get it going. That's really kind of really important thing. We didn't do brilliantly in terms of executing against this strategy, but what it meant was that we had hooks in everything for getting when we got this strategy going to get it there. It took us quite a while to find the right QA engineer to really drive that strategy out and to build it out. I'm really pleased to say that we've got someone now who is doing a fantastic job, but they're behind. They didn't start until we were 10, 11 sprints in, so they're behind and they're trying to catch up. And as we're building that out, that becomes a thing. We don't have a performance test environment yet or any performance testing, but you can see here, because it's in the plan, we've got a kind of hook for it. We know where it fits. So when we come to build it, it's not trying to re-engineer everything backwards. So I think making sure there's a good testing strategy in your pipeline, in your process thinking, that sort of stuff, I think is really, really important. And that's a very I think a key part of the DevOps crossover is that automation of testing to get through CI and CD well, and to be able to trust your CD in particular. If you're going to go down that route, to be able to trust that, you have to have this great testing strategy, and you'll never get there really until you do. So sticking that in from the beginning was a good thing to have done. However, that came at the cost of monitoring and alerting. We didn't do this because we thought, no, it's fine. We don't really have production customers, not yet. Etc. And you can see here two great examples of where a little bit of monitoring and alerting would have, saved us lots and lots of work. So monitoring and alerting really, really not optional. You've got to make sure that's built in right from the very beginning. And we are now having to reverse engineer that in. Thankfully, because audit and logging is such an important part of food production, like it was for medical devices, we built that in. So we do have the raw materials to do monitoring and alerting properly, some of the raw materials to do it properly, but we need to get better at it. Something else I feel we did quite well was setting and enforcing coding standards. Coding standards sounds like a really dry, boring topic. It's really easy to do. It's really easy to build it into the pipeline. You absolutely should. Using tools like SonarQube, using tools like CodeSmells, using copy-paste detectors. If you're writing Python, use the black tool. Use your IDE to drive your coding standards. Getting that done right, and to answer the question I probably haven't been asked yet, 4 spaces, not a tab. To getting that right is really, really important, and it sets early on, right at the commit point. It sets a focus on quality, and that focus on quality then drags its way through, all the way through into actually what you deliver. So even as things as simple as that, and I think we did that quite well. Don't know how this one's going to turn out. We have microservices in a mono repo. I've said microservices versus mono repos. Actually, our microservices are in a mono repo. This gives us a lot of advantages, but it also costs us a little bit of confusion, a little bit of difficulty. While we're a small team, it's kind of working, but I can see very quickly as we increase the size and scope of the team that it's going to slow down, and particularly as we increase the size and scope of the software. Right now, because we have a mono repo, there's no easy way to get it to build only certain images depending on what's changed. We can do things like, put a mapping together between this folder to that, to this Docker container, that one. So if anything in this folder changes, we need to rebuild. But that's quite brittle. And if you're growing at speed, then the things can get out of sync quite quickly. So we don't know how this is going to work out just yet. Right now, it's kind of okay. But I suspect we're going to learn that as we grow out the size of the team, grow out the size of the software, grow out the complexity of the architecture, this is going to come and bite us, I think. Yeah, so we started off doing this poorly, and now we're doing it much better. Don't roll your own security. There's lots and lots and lots of teams, lots and lots of tools out there that allow you to do security much, much better than if you roll your own. We started off trying to use Microsoft Identity Service C# platform, write that all ourselves, and it quickly became clear that that wasn't going to work for us. We've selected to use Azure AD. We're an Azure client, Azure tech stack. We're C#, and so it makes sense to use Microsoft and Azure. But there are plenty of others out there. Zero Auth0, Okta, you name it. There are loads. Google even provide a security and an identity provider platform. Use theirs, and that actually rolls across the whole of the piece. If there's a good solution out there already, don't roll your own. Use it, and we're learning that lesson, particularly around security. But we're actually learning that lesson across several areas of the application. And when it comes to security as well, don't forget that not only do you have to roll your own, well, I'm gone. Not only do you have to roll your own OAuth pipelines and everything else, you then have to take on single sign-on. You then have to do user management within your application, rather than just hand that off to your identity provider. Also, you're going to start having to do API tokens at some point, and if you're rolling your own, token management can become a real pain. So let's just use a solution that's out there. So not sure how this goes. One of the tenets we've had architecturally from the beginning is the right tool for the right job. Right now, everything is built. Some of the DevOps stuff is in Terraform, mostly in YAML, Terraform and Helm and that sort of stuff. But the code itself is written in these two languages. The reason behind that is because these are the two languages we can code. So I've got a Python background, as well as my PHP background, and the team is mostly recruited out of C# engineers. At some point, we're going to come into some problem that doesn't work particularly well in C#, and then I try and do it in Python and fall hard on my face. And at that point, we're going to need to expand that technology tree. Right now, I don't think we're brilliantly suited for that. We've got lots of expertise in C#, we've got a little bit of expertise in Python, but we don't have a big broad range. So it's really important to make sure that we don't get solution focused into C# and Python, because that's the only way it does it. So I think that's something I'm going to have to keep an eye on. Eventually, I will employ a proper architect who understands what they're up to, and think they need to help in that. And I'm also hoping that our DevOps team, as they look at the solutions that are coming through, are asking those sorts of questions of us. And then the final thing, we did well. The final thing we did well was parking data management. You remember from that very first slide, I said we tried to eat too much of the elephant. I was talking about ETLs, I was talking about data lakes, I was talking about everything else. I don't have any customers. I don't have any live data. So I could build all this stuff, but I don't have anything to populate it with. So I'm likely to build the wrong things. So we parked these things here. To sort of say we'll do that later, and that was such a good call, choosing again to narrow our focus and do things. We're actually working now with a pretty capable data scientist who's going to start advising, now that we know what we're doing on terms of the actual software, who's going to give us some advice on how to build out the first parts of these, the first parts of getting into a data warehouse, data lake kind of space. So that was really important. I do see one more, sorry, that we had. We decided to avoid vendor lock-in, and that came as a knee-jerk reaction from me without really thinking about it. Of course you avoid vendor lock-in. Get on Helm, get on Terraform, do the stuff. The difficulty with that is, and why I'm saying we'll see on this, is actually, even though we have built everything in Kubernetes, and we could ostensibly pick that up, and everything's a Docker container, and we could ostensibly pick that up and drop it into AWS, or drop it into Google Cloud, or drop it into DigitalOcean, or even drop it onto our own hardware, in a data center somewhere. There's actually enough sort of hooks in this stuff that we couldn't do it overnight. It would be a significant task to take on. So avoiding vendor lock-in seemed like a good idea. We'll see if it is, and actually if it would have been better to just go for vendor lock-in and really leverage some of the tools that Azure can give us. in some of these spaces around here. It's a question we're continuing to ask ourselves. And that sort of hits me, about 9 minutes overdue. Sorry about that. I love talking. I love the sound of my own voice. That brings me to sort of the end of my bit, but I'm hoping that from those lessons that we've got some questions that might start a bit of conversation. Harry?
We have indeed, yeah. There's a few questions here. One that's just come in, more of a comment really than a question, is no vendor lock-in is not always the best approach, in my opinion. You miss out on the value add to the cloud providers and end up with the lowest common denominator. Yeah,
I think we're learning that lesson. I genuinely think we are. We have another product in the company where we have accepted vendor lock-in a lot stronger. So we're using Azure IoT Hub and Azure IoT Edge Hub, and we're really locked into that. And we've got Azure functions running and Cosmos DB and Power BI and that sort of stuff. And what we were able to see is we were able to build something very quickly there to get lots of value, leverage lots of value. So I think we're learning the lesson that no vendor lock-in is not always the best approach. And so in our case, because we're not going to have millions of users and we don't need to protect against an Azure outage and be able to fail over instantly to Google or be able to fail over instantly to AWS, I think I made a mistake there, and I think we might need to look at that in the future as we iterate. Yeah.
Brilliant. Nathan has asked, what level are you monitoring / alerting at? Are you looking at hardware components, microservices level, or overall status level?
A little bit of everything. So looking definitely at the hardware level. We also our App Insights tool allows us to see the messages that are being passed between each of the microservices, and we can watch for particular key messages that tell us that something's wrong, and so we're alerting against that as well. We also then have in the app alerts. I'm calling them alerts because I'm being generous. Really, they're warnings. So you can see when you use the application, you can see a sort of recent watering. So you know not to move that tray because it's full of water, and if you move it, it's going to slosh all over the floor, and then you're going to spend the next 25 minutes mopping all that up. So it's fairly nascent, but it's across all of those different areas, and really it's something we're going to have to work on quite hard to play catch up on from where we started.
Perkins has asked, when are you planning to make the decision re microservices? If you leave it too late, it becomes really hard.
Okay, so we are microservices, definitely. One of our services is a bit massive and needs splitting up. We've made that decision. We haven't done it yet, and we haven't programmed getting it done, but we think we understand what we need to do. The key really is about the repo at the repo level. Certainly from a DevOps site reliability engineer continuous deployment point of view. At some point, we're going to need to split that repo up and take some of the pain that's involved in having. We're looking to take that decision soon. We need to understand it a bit better, I think. And we're a startup a few months away from delivering to our first customer. And we're not talking about small stuff here. We're talking about big stuff. So right now we're under the cosh to deliver far more than we could possibly achieve, and we're trying to sort that out. So there is a little bit of having to be pragmatic about saying, not right now. We know we need to do this, but not right now. So we have we write down all the nonsense, all the technical debt that we're building up, and then we get the product owner in the room and we go through it with them. And so the product owner is able to put about 30 to 40% engineering stories in. So we will get to this. It will happen, but it's just not happening right now. Anything else, Harry?
Yeah, there are a couple of questions that are quite similar here. So Chris has asked, how has lockdown affected the team, given that you are fairly early in the project and you're still growing and adding new members? Has there been any particular challenges? Pam's also said, have you all been working remotely? And if so, being such a new, fast-growing team, what challenges have you had and how have you addressed them?
Yeah, okay, so that has been really difficult. So We were, I think, 6 or maybe 7 in size the day the lockdown happened. The day after, we were +1. So literally someone started the day after we all went home. And it has been difficult. We discussed it actually before we all went home. We knew it was on the cards. And we sort of had a chat about how we might deal with it. And one of the things that we said we wanted to do was make sure that we didn't lose the ability to just turn around and chat to each other. So one of the things we did really early on was we set up a Discord channel. I don't know if you're aware of Discord. It's a gaming sort of chat thing that you can put on the background and talk to your mates while you're gaming with them, and laugh at each other as you shoot each other from miles away. It's great fun. But we put that on corporately, and we said we'd all be in it all the time. So that at any point someone could just go, oh damn, and everyone would just be there and go, oh, what's up, mate, and create that. It didn't work brilliant. It worked very well, but it didn't work brilliantly. Very quickly, people were in that channel, but they had their headset off, or they were muted, or they were something, and there was just creeping in a little bit of presenteeism, which is not helpful at all. So we started working out. We split the channels out. We started doing slightly different things. The other thing that we did is that the Scrum Master and I, we meet several times a week, obviously, but we met specifically and started talking about how we could look after the team in this scenario. And we knew that getting them talking and getting them trusting each other is absolutely key, and building trust in any team is absolutely key. And so we were wondering how we could do that. And one of the things that we observed was that lack of information, or a vacuum of information, fills itself with nonsense, basically, and fear and assumptions and that sort of thing. So we have several regular meetings where the whole team comes together, and we talk about things that aren't tickets, and we talk about things that aren't the growth tower, and we talk about things that aren't the software and aren't the everything else. So we have a knowledge sharing. So anybody who's been out into the rest of the business for any particular thing, we share knowledge there. We invite external speakers to that. So once a fortnight, 1 hour, just talking about the company at large, where our investors are, what happened at the board meeting, what happened at the management team meeting, head of HR comes in and gives us a chat about something, delivery project manager will come in and talk to us about something. So we have that. We also have regular as clockwork, a working from home review, where we all sit around and give ourselves a score for this week. This week, working from home has been 8 out of 10 because these brilliant things happened. This week it's been 4 out of 10 because I am threaders with being inside. And we all offer each other support and also advice about what we can do and what we can't do. And it's really, I really like it. It's really cathartic, and it helps build that kind of village atmosphere. So it has been hard work, and it hasn't been without its difficulties. When the advice in Scotland looked like it was going to be, you could all reopen your offices, we did, and we certainly have reopened it if we need to come to the office for any reason, and our office is still open for that. That was misinterpreted as you must come back to the office. But even then, once we fixed that misinterpretation, there was a sort of a mismatch between our understanding of where we were going to be and what we were going to do, and it was really important to get to the bottom of that of that problem, and we did. And it comes through communication, talking, accepting other viewpoints, and really, dare I say it, rolling back to the retrospective prime directive, is that we have to spend time believing that everyone is doing the right thing for the right reasons, and that people aren't just being nasty and unpleasant and mean on purpose. If that's the way it's coming across, one, tell them, they'll be mortified, and two, it really isn't what they were intending. And there's a truism that is, we judge other people by their actions, we judge ourselves by our intent. What we've tried to do is we've tried to get a little bit of empathy going and try to help each other judge people by their intent rather than their actions, and that has allowed us to have a much closer communication pathway. And then the slightly over-engineered process has helped us to keep that process in train. And the final sort of pin in that particular voodoo doll is that we have a fantastic Scrum Master. She's absolutely brilliant at keeping us on track and keeping us talking. And she has regular one-to-ones with all the members of the team, and to be able to bring that information back into the team and that sort of stuff. So it has been hard, but we so far, fingers crossed, it feels like we're weathering the storm.
Brilliant. Pam's just said, as well as team meetings for general updates, we have coffee time every Tuesday, which can be work or social chat, as if we were at the kettle.
Yeah, absolutely. I mean, that's what our working from home review is. It's a little bit more structured, but it is that kind of thing. We also start every meeting. So every meeting starts on time, but it doesn't convene until a few minutes into the meeting. I don't know if that makes sense to people, but at the start of every meeting, there's a bit of chat and a bit of banter, a bit of getting to know you, a bit of sharing what we were doing yesterday, that kind of stuff. And that's really important. Our Scrum Teams meeting, we use Microsoft Teams. Our Scrum Teams meeting always starts 5 minutes before the Scrum starts. So anyone who's free just jumps in and has a quick chat with each other and that sort of stuff. And we try and look after each other that way. Yeah, but a coffee morning is a great idea. In fact, it's such a great idea. I may steal it.
Dominic has asked, how often are you recording data such as temperature, light, nutrient level in sumps? Every second, every minute?
So that depends on who you are. If you are the machine, you're doing it every 100 milliseconds or so. But the machine is all internal inside the building, and it's feeding that information back into its own feedback loops in order to make micro changes, that sort of stuff. In terms of how often we're extracting stuff out of that in order to create metrics and in order to create graphs, we're looking at about, depending on the metric, we're looking at either sort of once every 30 seconds or so, all the way through to once an hour, depending what they are. In fact, we take photographs of the crops as part of the process, and we have a camera on the lift. We take photographs of crops, and they get taken every 12 hours. So that's data we're gathering every 12 hours. Some others are gathered every 30 seconds or so. But the machine itself is spinning through the PLCs. The way they work, they run through basically an infinite loop of code, and they run through that every 100 milliseconds or so. And they do everything they're supposed to do. It's quite a clever setup. It's called ladder logic. It's so you kind of cascade through the logic of it. Those are available to us, updated all the time, but we probably only grab them every 30 seconds or so.
Fantastic. So that's all the questions for now. Has anybody got any sort of final questions or any comments that they want to ask Gordy? Just give a couple of minutes in case anyone's typing it out. I really enjoyed that though, Gordy. It's really, really fascinating stuff, and I think there's a wealth of opportunities and things that can come from this, definitely.
Yeah, I mean, it's a super exciting area to be in, and the technology and how we're leveraging it is also super exciting. We've got so much to learn, and I think we can leverage much more out of the technology over time, and that makes me super happy. I mean, I don't know if you can tell, but I'm a bit up about the company, about what we're trying to do, and how we're doing things. Yeah,
I've had some nice comments coming through. Nathan, great press and insight. Thanks, Gordy. Pam, I really enjoyed this. Thank you. Ian, excellent, great ideas. Brian, great session. Thank you for your time.
Thank you.
Mark has said, just lost it. Mark said, really enjoyed the talk. Looks like an amazing project. Philip, thanks. Was really interesting. Paul, great presentation. Thanks, Gordy. Morag, thank you very much. Fascinating, helpful, and a lot of food for thought.
Thanks very much, everyone.
Fantastic session. Really enjoyed this. Stefan, great stuff, Gordy. Ian, yeah, it just keeps coming. Really, really good. I think I've really enjoyed that. I think it's a really, really interesting topic, interesting sector, and what you're doing it seems to be really brilliant. So I'm really grateful that you've come on and done that for us.
Okay, no problem at all.
Any final questions from anybody? mean, a lot of people have said sort of thank you, so I imagine we're probably concluded there. Hi Rob, how you doing?
I'm good, and just a quick comment to Ian, who asked in chat. Yes, the session has been recorded, Ian. It'll probably take less than a day to get it all in and out there, and I'm quite sure we'll obviously pass a version over to Gordy, a version will go to Harry as well. You'll be able to get your hands on it somehow, but yes, the session has been recorded in full.
Yeah, and I'll provide Harry and Rob with a PDF of the slides as well, so you can review those. I think some of the lessons learned stuff is pretty cool.
Yeah, that's amazing. That's amazing. So we'll make that available for everyone. Once again, Gordy, thank you so much for that. It was really, really good. If anyone does have any questions that maybe comes to you after this, drop an email or a message in the meetup group, and I'm sure we'll get them across to Gordy so we can answer them. Obviously, we run these every month as well, so everyone join onto that meetup group if you haven't already. There is going to be more events coming, and we'll be releasing the next one fairly shortly. So if there's no other questions, Gordy, again, thanks so much, and
More than welcome.
yeah, a great evening.
Excellent.
Thank you, Gordy, and thank you to everybody who took part. Thank you for your questions. Thank you for the interactivity. Makes a massive difference to the presenter to get that interaction going with the audience. So thank you all so very much for taking part this evening. That's it from me. Thank you very much again.
Thank you very much for your time.
Cheers, guys. Thank you.